Okay, everybody, this is chapter 6, section 2. It's properties of parallelograms. So if you guys would mind, please writing the word parallelogram, and then I'm going to have to write the definition for you. So it's a quadrilateral. Remember, quad means four. Lateral in this case means side. So four-sided figure that has opposite sides being congruent and opposite angles being congruent. Okay. So let's just really quickly draw a parallelogram, because parallelograms, for what we're going to do, encompass a lot of different rules that are applied to other quadrilaterals like rectangles and squares and rhombuses. Okay, so let's show that opposite sides in this case are going to be also, I forgot I got to add some here. Opposite sides are parallel, because that's where parallelogram comes from. And then opposite sides are going to be congruent. Okay, so these sides are congruent, they're opposites. These sides are congruent, they're opposites. Okay. Also, too, in that definition, opposite angles are congruent. So these guys are going to be congruent, and then these guys would be congruent to each other. Not all four angles are equal in this case, but opposite angles are. Okay. And just very quickly, kind of going with the definition we got, there's 6 theorems here that go with a parallelogram. Some are the converse of each other. Some are kind of in that definition we just had, but it's really important that you write these down. So theorems about parallelograms. And, you know, like I said before, and when we do these videos, I go kind of quick. So, you know, if you're getting behind, hit pause, get caught up, hit play again, come back. I'm going to draw some of the diagrams here to these different theorems as you're writing, okay? So number one, if a quadrilateral is a parallelogram, then its opposite sides are congruent. So I kind of did that one for you a second ago. Opposite sides are going to be congruent. Not all four sides are equal in this particular case, but opposite sides are congruent. And let's just bring up something. You know, a square is a parallelogram. You'll find this as we go along. A square is a parallelogram. Are opposite sides in a square congruent? Well, yes, they are. Are all four sides congruent in a square? Well, yes, they are. But that still fits the definition of what a parallelogram, because it's just saying opposite sides are congruent. In a particular parallelogram, though, they're not all going to be equal. Okay. The second theorem, if a quadrilateral is a parallelogram, then its opposite angles are congruent. So I kind of did that one for you in the definition too. Opposite angles are going to be congruent in a parallelogram. Okay, now when you hear the word parallelogram, you're making an assumption here too. All the side or opposite sides are going to be parallel. So I kind of drew that in the picture we had before. That's what parallel means in parallelogram. Opposite sides are always going to be parallel. And then for this theorem, opposite angles are congruent. So let's think about a square again. A square is a parallelogram. Opposite sides are parallel. And the opposite angles are going to be congruent. Well, in a square, all the angles are 90. But you got angles that are 90 that are opposite each other. So a square still fits in the definition of what a parallelogram is. Okay. For the next theorem, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary, and we might want to change this to same side. Okay. And remember, supplementary means 180 degrees. Same side would be coming from the transversal we did in chapter 3. Okay. Remember that? It's a parallelogram. That means you got parallel sides, which means if if I got parallel lines and parallel sides, I can draw a transversal. We did that when we talked about alternate interior angles. Well, now if I've got my transversal going on here, the same side interior angles are going to be these guys, and I'll call them X and Y because they're different, but X plus Y should be 180 degrees. Okay, so let's make sure that this is another rule or key that we need to make sure that we have down here. Consecutive just means they're kind of on top of each other. We know them as same side interior angles and a transversal. Okay, so we're using those rules again. The last theorem down here, if a quadrilateral is a parallelogram, then its diagonals bisect each other. So let's do this. Parallelogram. Diagonals are these guys. And they bisect each other. We got to remember what the word bisect means. It means it cuts into equal parts or equal segments in this case. So this is going to be equal to that, and then this is going to be equal to that. Okay, so the diagonals each get cut into equal halves. Doesn't mean they're all equal to each other, especially in the parallelogram. In a parallelogram, one diagonal is actually longer than the other. Okay. Okay. So if you guys go ahead and draw this figure and then label it all up with the measurements they give you and the letters that they give you. Okay. And it's a parallelogram. So what we know about parallelograms, all these theorems and the definition I gave you at the beginning, we got to know these. So right now, yeah, you just learned them, so we got to use our notes, but make sure you go back and study your notes and have this stuff down. So JH is the bottom, okay? And I believe that it's an opposite side of FG, and they tell me that FG is 23 in a parallelogram. Opposite sides are congruent, so JH should equal 23. Okay? So you gotta know our rules. JK is this. Okay? And they tell me it's a parallelogram, and a parallelogram diagonals are bisected by each other. So they're telling me that KG is 16. Well, KG is the bisected side of JK, so they must be equal by the theorem. Okay, gotta know this stuff. GH is going to be this side right here, and once again, I go back to the other rule that opposite sides are going to be congruent. I'll use 3 since I used 1 and 2. So these two sides must be equal because they're opposite. So GH is going to be 19. Okay, so bunch of rules there, kind of wound them all up in the definition that you had. Just got to have all these rules down. The best way to do is studying it, not guessing it. Okay. If you guys could go ahead and draw in this next figure, label it all up, and then with the vertices, then label it with the measurements they give you for the angles inside. Okay, they want you to find the measure of angle A. Okay, a couple different things we could do here. One, it's a parallelogram is also a quadrilateral, and we learned in section 1 of this chapter that all quadrilaterals, the interior angles equal 360. So I could maybe use that. But one of the theorems we also got was that opposite angles are going to be equal. So A and C are opposites, and if C is 78, then A should be 78. Okay? And we've learned as we've gone through these chapters this year that as we go along, some of these rules that we have, you know, we start using them here and there, and different chapters have rules that come up in other chapters. We just got to have all this stuff down. Okay? Now, angle B, you know, opposite angles should be equal, but there's nothing over there for D. How do I do this? Okay? But we also learned, too, that same side interior angles in a parallelogram. So remember, sides are parallel, therefore I get a transversal. the new rule with this transversal, with these rules of parallelograms, that these two angles, A and B, should be supplementary, okay? So I should be able to take 3x, and A was 78 because it was opposite this guy. They should equal 180 together, okay? So I'm going to subtract, I'm going to set up that equation. So a pretty important rule for us. Set up that equation, solve it for x, to subtract 78 from both sides. I get that. I'm going to go ahead and divide 3x by 3 and the other side by 3, and I get 34 degrees for x, okay? So they asked me to solve for x, I get 34 degrees, sorry. But I might ask you to find angle B, so I need to plug that back in, and angle B is going to be 102, and that kind of made sense because 3x is equal to that other angle, and that other angle should have been 102 degrees anyways, okay? So be prepared to do that plugging stuff. All right, if you guys can go ahead and draw this picture, this is a test question, and this is kind of a more using common sense and some of the rules that we have learned, okay? So if you could draw this and label all up, this is on a graph. So this is the y-axis up here, and this is the x-axis down there. That might help you a little bit with this one, okay? Lots of kids historically always have issues with this because we're using letters and trying to use letters to state a value for something. We're not used to doing that, okay? So once again, we're going to take all those theorems that we had about parallelograms and try to apply this to this particular problem, all right? What we have to really do is find the coordinates for C, okay? And they tell me that it's a parallelogram. So let's just do, first off, all the sides, opposite sides at least, are going to be parallel to each other. So that's kind of helpful, but also they're congruent to each other. So let's kind of show that, all right? And so, you know, if you kind of look at this, if you look at the distance from here to the axis, and then you look at, you know, if I kind of did this, show that that was at a right angle, then I'm looking at the distance here too. That's kind of key in this question, okay? So at C, I'm trying to find, you know, a value for that, all right? What kind of a key here too, this point right here is 0, 0. So I got real numbers, okay? And this point down here at D is whatever the distance here is going to be, we're going to call it Z. It's the X value at some point out here. They called it Z. The Y value is 0, okay? If you look to up here at D, the X value right here is, they're calling it X. And the Y value right here is calling it Y. Now, if you really understand graphs, and you should at this point, that if I go this way on that line, the X value is always going to change. It's going to increase, but it's changing. What happens to Y along that line? Does Y change, or does it stay constant? Well, Y is going to change as you go up. So Y out here is not going to change. So at least I know now that my Y value at C is going to stay Y, where it was, you know, whatever that value was at B, okay? Now, when I try to get an X value, I'm looking at the distance X is from the Y axis. So I'm looking at both of those, that whole space between the Y axis and then going all the way out to C. What can I use to represent the X value at C? And I want to think of distance in this case. So did I go this distance? Change my color here. Did I go this distance? Yes. Did I go this distance? Yes. What represents that? Well, it's two segments put together. This segment out here is represented by X. This segment out here is really represented by the whole distance here because these sides are equal. And this side had a length of z, so this side should have a length of z. Whatever that is. We don't know what it is. So to give me a representation of this x value, it's the length of x and the length of z gives me what x and y would be, or x would be out there at C. Okay. So kind of a theoretical thought process there, and using a little bit of common sense. Sometimes we overthink it. Sometimes we go, oh, what the heck? There's no real numbers there except for 0. How do I do that? Well, can I add two segments together? Yes, I can. What were the segments? Well, one was x and one was z. So that would help me put those two together just to represent what is the x value at C. Okay, so make sure you put a big old star next to that one. Go back and look at that. This is a test question. Typically shows up in a chapter test and on your final. So I want to make sure we got that one down. Okay, if you go down to example 4, if you go ahead and draw that parallelogram for me, please, and then label all up what the angle measures are. This is another really good question. It's just making you think, making you take the different rules that you have for a parallelogram and use it to, how do I get started here? Okay. Okay. So parallelogram, opposite sides are parallel. Opposite sides are equal. Opposite angles are congruent. And then same side, because you got a parallelogram, you got a transversal. In this case, in a transversal, same side interior angles are going to be supplementary. So there's all my rules that go with a parallelogram. How do you get started? Well, you got to solve for the variables x, y, and z. So 3 different variables in one problem. How do you do that? Well, which rule gives you an opportunity to solve for one of the variables? Well, I know that 4y should be equal to 3z, but I can't solve that. Opposite angles are equal. The other opposite angles are this: 2x plus 12 is equal to 3x minus 18. That might be beneficial to me because now I got x in the same equation. So let's start there. Okay. I could also say, just coming over here to the 180 side, 4y plus 2x plus 12 is equal to 180, but I got 2 different variables. That doesn't help. I could go 3x minus 18 is equal, or plus, I'm sorry, plus 3z is equal to 180 again, but once again, I got 2 different variables. And I just want to point something out here. My transversal really goes in 2 different directions. I could go 4y plus 3x minus 18 equals 180, and I could go 2x plus 12 plus 3z equals 180. But all 4 of these combinations are not helping me at all right now. I might come back to them a little bit later, okay? But this is where I can start, and this is you guys just getting an idea of your rules and know how to play the game. So I'm going to solve for x. I'm going to subtract 2x from both sides. I'm going to get 12 equals x minus 18. I'm going to add 18 to both sides, and I get x is 30. Okay, so I got one of the variables out of the way. I'm good to go. I don't have to plug it back in because it's not asking me for the angle measures. It might, and that might be helpful too. So let's go ahead and plug it in anyways. So I go down here, I put x in, 30 in for x. So I get 2 times 30 is 60, plus 12 is 72 degrees. Okay. Go ahead and plug it in over here where the other x is. 3 times 30 equals 90. 90 minus 18 also gives me 72 degrees, and it should be because they're opposites and they got to be equal. Okay, so there you go. Now what I could do is I could go back and let's use this one now. Same side interior angles are going to be supplementary, parallelogram, and I already know that 2x plus 12 gave me 72 degrees. So let's substitute that in and go 4y plus 72 equals 180. Okay, subtract 72 from both sides. I get 108. And I'm going to divide both sides by 4. Y equals 27. Okay, so now I got x and y, and I got z. Now you got multiple ways to do this. The easiest way I think is set these two equal to each other. Okay, now kind of cheating here. Back here, 4y equaled 108. So let's put 108 in equal for 4y and set it equal to its opposite angle. In this case, it was 3z. Okay. I can go ahead now and divide both sides by 3, and z equals 36. Okay. So, huge question there. Just the perfect question to take everything that you need about parallelograms and applying it and using it in many different ways. That was one way to be able to do that problem. There's a couple other ways you could have done that. I thought that was the easiest way to start because you had equal angles that had the same variable in it. I could solve it that way. After that, I got different ways to go from there. These are just the way I did it. Okay. All right. If we go down to example 5, if you guys could go ahead and draw that, please. If you guys could also write what's given to me, and we're going to write a 2-column proof for this. Draw the picture because we're going to use the picture. Okay. So ABCD is a parallelogram, and we need to prove that AB is congruent to CD and BC is congruent to DA. And you guys that are really smart and got this, well, they should be congruent if you're telling me it's a parallelogram, but we have to go and prove it. Okay. So I want to go back to a previous chapter. You got a parallelogram, but now it's got a diagonal through it. What's the diagonal doing? I believe it's cutting it into 2 triangles, and we go back to that triangle stuff. If I know my stuff, I'm going back to this stuff that we learned a while ago, and then a couple other things we can use. Okay, so let's just go ahead. ABCD is a parallelogram, and let me also just show you this too. My fault, I didn't do this. There's a symbol that we use for the word parallelogram because it's so long, and we screw up the spelling on it. You can use that symbol for the word parallelogram, and you'll see that in the textbook and other things. Okay, so we were told that ABCD is a parallelogram that's given. I have to prove that these sides are equal. Okay, so what do you know? What do you see? Well, first off, I'm going to say that AC equals AC, and that's by reflection, or the reflexive property. Okay, remember, start telling me what you know and how you do it. They told me it was a parallelogram. Well, if it's a parallelogram, then I must have a transversal because opposite sides are supposed to be parallel. Okay. If you go back to a different chapter, when we have this, you got a transversal like this, I should be able to think that alternate interior angles are congruent. So I can go angle 2 is congruent to angle 3 by, hold on, let's see if I can write correctly, angle 3 by alternate interior angles. And I think we talked about this before. Remember, in a transversal, you actually got 2 pairs of alternate interior angles. Okay, so we can go angle 4 is congruent to angle 1 by alternate interior angles. Okay, so let's kind of review here a little bit what we got. Remember I said we hit this parallelogram is cut into two different triangles, and I might need to go, hey, prove it by one of these guys. And remember, these are pieces of those two triangles. So if I'm trying to prove that pieces are congruent, I could use that one rule we used, I believe, back in chapter 4. Do you have that now? And I do. I got angle, side, angle, congruent to angle, side, angle. So I can say triangle, we'll go A, B, C is congruent to triangle CDA, and that's going to be by angle, side, angle, which then allows me to say that AB is congruent to CD and BC is congruent to DA by CPCTC. So once again, using all this stuff, we've used some different chapters to maybe help us do that. I could have drawn my transversal the other way because, now these sides are parallel. I could have done my transversal this way, and I could have used same side interior angles or supplementary and done that. So more than one really correct answer, but I'm still getting down to this last step, being that the same way. The previous step proving by one of the triangle congruencies that we had up there, okay? All right, so that takes us to the end of 6.2.